Lesson 8, Implicit Differentiation. Sometimes it might be too difficult to rearrange an equation into the form y equals f of x or x is equal to f of y to find the gradient. You can sometimes differentiate these implicitly without having to rearrange them. In general, if you differentiate a function of y with respect to x, it's equal to the derivative of that function if you differentiate it with respect to y instead of x, multiplied by dy over dx. These two results are useful for implicit differentiation. The derivative of y to the power of n with respect to x is, using the rule we just learned, differentiate this with respect to y. So let's bring the n down, multiply by y, reduce the power by 1, but then we multiply this by dy over dx. That's the first term. That's the first result. Second one, the derivative of xy with respect to x, you can use the chain rule. So we differentiate the first term. The derivative of x is just 1, multiplied by y is just y, plus you keep the first term, but differentiate y with respect to x is just dy over dx. So it's x multiplied by dy over dx. And so these two both are useful for implicit differentiation. Differentiating implicitly usually gives dy over dx in terms of both x and y. Let's do some examples. Let's find dy over dx given that x cubed plus x plus y cubed plus 3y is equal to 6. If we differentiate both sides with respect to x cubed differentiates into 3x squared, x differentiates into 1. Now y cubed, as we just learned, you differentiate with respect to y, so this becomes 3y squared multiplied by dy over dx, and 3y differentiates into 3 dy over dx, and 6 differentiates into 0. Now we can factor out the dy over dx to get 3y squared plus 3 is equal to, if we bring the 3x squared plus 1 to the other side, is equal to minus 3x squared minus 1. And so therefore, dy over dx will be equal to minus 3x squared minus 1 over 3y squared plus 3. Let's do another example. Let's find the value of dy over dx at the point 1, 1, where e to the 2x multiplied by the natural log of y is equal to x plus y minus 2. Again, if we differentiate both sides, we use the chain rule for this. So e to the 2x differentiates to 2e to the 2x multiplied by ln y, plus ln y differentiates to 1 over y. We differentiate with respect to y, and then multiply it by dy over dx. And this will be equal to 1, x differentiates to 1, plus dy over dx. Now, this should be multiplied by e to the 2x. You leave the first term. This is equal to 1 plus dy over dx. Now, you can either rearrange for dy over dx, or you can sub in the point 1, 1 right now. I'm going to do that. So, 1, 1, this makes ln of 1 is just 0, so this whole thing is gone. 1 over 1 is just 1, and so we're left with e squared, e to the power of 2, minus 1. If we bring this dy over dx to the other side, multiplied by dy over dx is equal to this 1. And so therefore, dy over dx is equal to 1 over e squared minus 1. And that's about it.